we have our next rule, which is the integral of 1 over x, and this is going to be equal to the ln of the absolute value of x plus c. We do need the absolute values there only because we can't have negatives on the inside of logarithms. So this is also kind of the problem child, if you will, of the integrals, because this is the problem because 1 over x, you could write that as x to the negative 1. And this is actually the only power that we can't use our normal rules on, because any other power we just up it by 1 and then divide by that new power. So here, that can't work, because if you up negative 1 by 1, you get x to the 0, which is okay, but then when you divide by that new power, you divide by 0, and that's where it breaks down. We can't do that. So that's why x to the negative 1 has its own rule. It's the only power that has its own rule, and it's ln of x. Again, if you think about the other direction, when we took the derivatives of ln of x, we got 1 over x. So again, it does make sense. So for number 11, we have 2 over x. All that 2 is going to do is just be in front of the ln. So 2 ln of x plus c. And the 3, all that's going to do is just be the 3 in front of the ln of x plus c. Technically, if you wanted to do this, I guess, a longer way or showing more, so if you want to, you can show that 2 actually kind of gets factored out, or you can factor it out if you want to. So if you want to factor out a 2 out of the integral, and that will leave you with a 1 over x dx, and then the 1 over x becomes the ln of x, and you have the plus c, and then that 2 comes down. So if you want to show technically what's going on here, you can, but it will always just work where the number, as long as it's a constant or a coefficient, will just follow along with the ln of x.